Alright, so we want to look at just creating a Mobius transformation from using 3 points to 3 points. So get this up here. So what we want to do is simply take Z1 to W1, Z2 to W2, and Z3 to W3, like that. And so to do this, we're going to have a Mobius transformation in which we're going to write A Z1 plus B over C Z1 plus D, and that's going to equal W1. Well, now I'm going to have 3 more of those. If I want to solve them, what I'll do, I can multiply both sides by the denominator here. So I've got AZ1 plus B equals, now let me write the C first. C Z1 W1 plus D W1. And then if I move everything to the left, I have an equation that looks like this, minus C Z1 W1 minus D W1 equals 0. Now I can similarly do that with Z2 and W2 and Z3 and W3. So I have this C3 W3 D W3 equals 0. And so this actually I can write as a matrix equation and solve it that way very quickly with technology. So what I'll do is whether you've had matrix stuff or not, I'm going to take the actual coefficients, not the A, B, C, and D, but the coefficients now, since the A, B, C, and D are unknowns, the coefficients are these other things. So I'm going to make a matrix that's Z1, 1, minus Z1, W1, minus W1. So these are the coefficients on the A, B, C, and D. Z2, W2 here, minus Z3, W3 here, and minus W2, minus W3. So I'm going to actually use that matrix. Now what's going on is I'm multiplying by A, B, C, D here, like this, and I get zeros on this side. So I can just work with this in Sage, and what I'll do is what's called a reduced row echelon form. Okay. And what that does is it goes through solving for my variables, and what'll happen is it should end up with an answer like 1 0 0 0 1 0 0 0 1, like this, and then the last column is going to have minus A, minus B, minus C in it. Now to make things easier in the code, I slapped a negative in front of this to make it negative 1 0 0 A, 0 negative 1 0 B, and 0 0 negative 1 C. And in this case, it's always assumed that D, oops, not equal to 0. That would be bad. D is equal to 1. Okay, so notice D doesn't show up here. It's always just going to be assumed to be 1 from this. And so, once you run that code, you'll be able to read off the coefficients like that, and you'll also be able to get the D. So let's take a look at this one that we know so well, I guess, at this point. If we have z minus 1 over I, z plus I, well, in this case, this takes 0 to I, 1 to 0, and I to 1. Okay, so it just sort of permutes these numbers here. And so I'll put that into the code, and we'll get the coefficients out and look at what that is. So I'll hit escape here, go here where I've already put them in. So here's 0, 1, and I, and that goes to I, 0, and 1, we said. Now I have some other points in here for later, but here's where I make that matrix of the z's and z's times w and so forth. Here's where I do the reduced row echelon form, but put a minus sign out in front of it. And so, reading this off, I get minus I, and 1. So if I go back here, I got A equals minus I, B equals I, C equals 1, and then of course D is equal to 1. So what would that say that this should be? Well, it says it should be minus I Z plus I divided by Z plus 1. But notice that is equivalent, because if I multiply top and bottom of this by I, then minus I times I becomes 1, so I get Z. I times I is a negative 1, so I get minus 1, and over IZ plus I. Okay, so we can have that. Now I can, I'm just going to take something arbitrary here and think of like, now of course, see, I know these answers before I do them, but that's just to, oops, there we go, got that. Back to the pen. Okay, so take something like this. So z minus 1 over 2. Now in this case I'll have 0, 1, and I. 0 goes to negative a half, 1 goes to 0, and I goes to I minus 1 over 2. Now I already have those put in, so we can look at what that is. So if I come back here and I comment these out, and then I do these, so there's my minus 1/2, 0, and I minus 1/2. I evaluate, and it says I get 1/2, minus 1/2, and 0. So I got A equals 1/2, B equals minus 1/2, C equals what was C? 0. Good. Should be. C equals 0, but then of course D equals 1. So according to that, I would have 1/2 Z minus 1/2 divided by 0 plus 1. But that's pretty easy to see that that is indeed Z minus 1 over 2. So this is this code is working and giving me the right coefficients for my Mobius transformation. So there we go. We'll call that good on that. I think that'll do it. Whoops, not sure what that just did, but hey, we're finished.